If simplicity can give rise to complexity, then it shouldn't surprise us that randomness too can give rise to patterns. But here's the catch. Our brains weren't built to recognize this. We are natural-born storytellers, not statisticians. And when we try to make sense of randomness, we often see cause where there is none, or miss the invisible structure underneath it all. This is especially true when it comes to probability. Humans are notoriously bad at intuiting probability. We tend to overestimate rare dangers while underestimating common risks, leading to irrational fears and poor decision-making. This is why people are more afraid of plane crashes than car accidents, even though air travel is statistically far safer. Similarly, many people feel more anxious about shark attacks than slipping in their own bathrooms, even though the latter is exponentially more likely to cause injury or death. Our inability to grasp probability leads to flawed reasoning, poor risk assessment, and widespread misconceptions about chance. A famous example of counterintuitive probability is the infinite monkey theorem, which states that if a monkey were to randomly hit keys on a typewriter for an infinite amount of time, it would eventually produce the complete works of Shakespeare. At first glance, this sounds absurd. How could randomness generate something as structured and meaningful as Hamlet? But mathematically, given infinite time, the probability of the monkey producing any finite sequence of text approaches certainty. However, many people misunderstand the implications of this theorem. First, the term infinite is crucial. In a finite time frame, even trillions of years, the likelihood of producing Shakespeare's works is astronomically low. Second, while pure randomness does guarantee all possible outcomes given enough time, it does not guarantee efficiency. The vast majority of what the monkey would type would be gibberish, and the occurrence of Shakespearean text would be so rare that even if we watched for billions of lifetimes, we might never see a coherent sentence emerge. Some critics argue that the theorem, while mathematically valid, is a misleading representation of how randomness works in the real world, where meaningful structure rarely emerges from chaos without some guiding mechanism. The failure to intuit probability is perhaps nowhere more evident than in gambling. One of the most common misconceptions gamblers fall for is the gambler's fallacy, the belief that past random events influence future random outcomes. A classic example is a person playing roulette who sees black come up 5 times in a row and assumes that red is now due for a win. But each spin of the wheel is independent. Previous outcomes have no effect on future ones. Humans evolved in environments where probability was not explicitly calculated, but rather intuited based on experience. Our ancestors did not need to compute precise risks. They relied on heuristics, mental shortcuts that worked well enough for survival, but are often misleading in modern contexts. This is why people struggle with large numbers and fail to grasp just how unlikely certain events are.